Ravi Mishra from CISO platform to talk about CISO.
To give you a brief background about CISO platform, you can read about the CISO platform here, but it was started to enable a collaboration between the good guys or the defenders. So we realized that the bad guys, the attackers, have a lot of places that they're collaborating. They are sharing source code, they are sharing botnets, they are sharing compromised devices and information, but there was no collaboration amongst the defenders. So defenders were not collaborating at all, or not as much as they should be, to defend against the advanced attacks that you're seeing these days. So with that aim in mind, CISO platform was found. So we have our own research team, but we also collaborate with CISOs and security executives from across the globe and industry bodies to do original research, develop decision-making tools, and so on. So some of our primary research areas right now include IoT security. That's what we'll be discussing shortly. Using AI for security decision-making, cyber crisis management, and so on. CISO platform has about 4,000 members right now. And if you're interested in working with us on any of our research projects or starting your own and helping, needing any help from our side, we'll be more glad to assist you on that. So with that, I'll hand over to Devesh, who'll be taking this forward.
Hi all, my name is Devesh. I work for Adobe in my day job. I am working as a computer scientist there. And I am also part of CISO platform, as Ravi just mentioned. So how many of you actually remember this date? Okay. Not many actually, but yeah. So this is the day, I could see many hands now. So this is the day when the largest DDoS attack on internet happened, right? So we should not forget this date. And what actually happened is basically few of the most visited applications or the websites on the internet were down for a considerable amount of time. So those include Twitter, Reddit, Amazon, Netflix, Spotify, couple of more, right? So what actually happened is it was an attack on the DNS service provider, which is known as Dyn. So Dyn is one of the largest DNS service provider, and most of the DOS was observed around the eastern side of the country. That is the East Coast. So at about like 7:10 and 7:20 a.m. in the morning, people around Eastern Coast in nearby New York and all those areas started having started feeling this problem wherein they were not able to access all of these sites. So and then it again happened around midday, 12 to 1:30 sort of thing, and then the third attack was observed around the evening. So it eventually turned out later after the investigation that IoT devices were responsible for this DOS attack. So let me explain how this attack actually happened. So so DNS is basically a stateless. It's a UDP protocol, right? So it does not have any ways to do a authenticity check. So basically people can spoof it. So what actually happened, the Mirai botnet, which is developed and that got released last month in the end of October, wherein Brian Krebs' website had the similar sort of attack, and the attackers basically released the source code of Mirai botnet. So it's now there in the wild, and people started using it for causing a lot of other botnets, which was responsible for the Dyn attack as well. So basically, what Mirai botnet does is it looks for telnet. Telnet, as you all know, it's like an insecure protocol, right? So it looks for open telnet and then try connecting to all those devices which are able to talk over telnet, and it has a list of common, popularly known default passwords, like a set of 60 passwords, which it tries with every device, logs in, converts it into a botnet, and then it spreads like that. So similar thing was done with the Mirai botnet, And you might be thinking that why did DNS caching did not solve this problem, right? So obviously, there is a mechanism by which you can set your DNS caching to be like 24 hours or even for multiple days. But normally companies don't keep it that long because of obvious reasons. Because uh, they might need to change their servers at the last moment, so it should not refresh that long. It should refresh immediately. So this is what happened with the Mirai botnet, wherein if you'd have seen in last couple of days, lot many similar attacks have been felt across the globe. The latest one was the Liberian complete country internet was brought down, and it is speculated that even Mirai is responsible for that. So this is a small picture of the outage that was expected, that happened on that day. And as you could see, it's mainly around the eastern side of the country. We as we were browsing from India, we were not affected because DNS of, say, for example, Twitter and all those bigger companies, where it was down for those people who were trying to access this from that part of the world. So how can this risk would have been minimized, right? So the most important thing is to do ingress filtering. So as you could see that a router on the internet has destination IP plus the source IP, right? So people like bad actors can basically manipulate the source IP, and even if they can have like 10 devices, they can spoof it to come from like 100 and million of devices. So the most important thing is to do ingress filtering, and as you would have seen, there is a complete RFC dedicated to it, RFC 2827, which talks about router ingress filtering. So that movement is still going on, but I don't think anyone is taking that seriously. And it goes by the name SAVE, that is source address validation everywhere. So it's all over there theoretically, but I don't think anyone is taking that seriously. So I'll hand over to Vishwas now for the next couple of slides.
Thanks, Devish. So myself, Vishwas Lakundi, I am a IoT consultant, and I mainly work on IoT security and device management. In the next few slides, I will introduce you to the security part of IoT devices and gateways. And Nagasai Arun from SensiBridge also contributed to these slides. So as you see on this slide, this is an end-to-end framework for IoT communications. So you have end nodes on the left-hand side and the touch points on the right-hand side. So in between, you have the communication link flowing through the hubs, gateways, the platform that we call commonly for representing the middleware, and then the applications. So applications could be from any vertical. It could be smart cities, smart homes, your smart industries, etc. And this end nodes are basically hosting temperature sensors or any kind of sensors and some actuators. They are the smallest links in this chain. And they are equally important along with the gateways. So the gateways could be edge routers or our smartphones. You have multiple radios on the smartphones. For example, your Wi-Fi and BLE and Bluetooth. So all of them, they're already working as gateways. And recently, low power wide area networks such as LoRa, you have heard about them. So base stations based on that, they work as gateways. So security in these devices, if you want to consider security from end-to-end perspective in IoT, we have to consider each and every link in this communication scenario. So basically, an IoT node would consist of all these things. This is not exhaustive, but mostly consists of these things. So you have a microcontroller in the middle where you put the software stack on top of your radio and hardware. So that software stack depends mainly on the application that you're working for. And you also have some energy harvesting modules, power source and storage on those devices, RF transceiver where the radio comes into effect. Yeah, okay. The RF transceiver where the radio comes into effect, it can be 802.15.4 or BLE or Wi-Fi, anything that you choose. And you have some external memory and some sensors and actuators. But the most important thing to note here is all these devices, IoT nodes, are highly constrained, whether in terms of memory, processing power, external memory that you can put, storage and everything. So in terms of security, this is a big bottleneck. So the software stack that you want to put on top of these devices becomes limited. So then you have to really be careful in choosing the algorithms, the cryptos, interactions with the gateways and everything. And also, it's important to note that the microcontroller part, it will be hosting the interfaces for the apps that you're running. And some RTOS, it's optional. You can also run these devices without any operating system. You can just run a scheduler, for example. And some device drivers and then some hardware layers that connect to the actual hardware that is sitting on top of this device. So it's important to understand from these end device perspective that you have to secure the end node first physically, because a lot of us only think about, when it comes to security, only the algorithms or the cryptos that are running on these devices, but the actual physical security of these devices is very important, because most of these deployments are in remote areas. For example, it may be a remote cave where you have the sensor devices running, right? So the actual physical security of these devices is equally important, yeah? And securing the network links that it is connected to. It may be connected to multiple network links. For example, it can be through a router or directly to a gateway or directly to the cloud, the device itself. So according to the network link that is connected to, you have to choose the security part of that. And device management, when you deploy these many number of IoT devices, managing so many devices is very important. So the device management part, in terms of maybe lightweight M2M or other regular protocols, it becomes very important. So on top of security, you need to choose some device management mechanism that is having inbuilt security mechanisms. For example, if you want to choose low power wireless devices for these end nodes, you have security in terms of DTLS, and you have HTTP and QoAP running. And you also have to choose a device management protocol in terms of lightweight M2M, which has inbuilt binding for QoAP and DTLS, just an example. And it's also important to provide security for admin operations. Most of these devices may or may not have admin operations on those devices themselves, so you have to have those security mechanisms maybe from a cloud. So all those administrative configurations you have to control. Operating system security is also very important. So based on the RTOS that is normally used in these devices, you need to provide security for that part as well. Patching in software firmware updates, for example. So all these remotely deployed devices, they need firmware updates from time to time. So how you actually securely do that firmware update and patching whenever needed, it's also very important. Otherwise, these devices are open to any attacks and hacks. And in many devices or many IoT device configurations, it may always not be in a mesh form. Yeah, so if it is just a ad hoc network or a device connected to a gateway in a star fashion, for example, if you bring down just one device, the whole network may fail. So unless it is a self-configuring, self-healable network, just bringing one of those nodes is enough to have the network down. So we have to be really careful in providing security for the whole chain. So as part of the CISO work group on IoT security, we are working towards a threat model. This is not an exhaustive list. This is just the beginning. We are trying to figure out what different kinds of attacks are possible and what is the vulnerability of these attacks and how it can affect those devices and networks. For example, you can spoof the node itself, the entire node, because there is lack of encryption in the device. So that leads to a lot of damaging action, Denial of sleep, because most of these nodes, they go to sleep mode most of the time. So if you somehow configure that the device is up more times than it is intended to be, then that is also a major problem. Yeah, so it can make many of the services unavailable to the network. So this is basically a MAC layer vulnerability. Similarly, device hardware and software modifications can lead to a lot of service disablements. Same as data tampering and data disclosure, it can also lead to loss of data and denial of service. So moving on to the gateway, so you usually have a gateway connecting multiple end nodes, right? So this is a bit complex in terms of what it consists of, but putting security on those gateways is much easier than putting security on those end devices, because end devices are highly constrained, whereas the gateway is not, right? So the gateway, it can have local storage and database, and you can run much more sophisticated security algorithms and software on top of that. Likewise, in terms of threats and attacks, it's easier to attack most of the end nodes than a gateway. And the gateway will also have the cloud connectivity as well as local or edge analytics. So you can run most of the analytics part in IoT on those edge devices or gateways. So in terms of security for the gateways, it's important to understand the difference between protocol translation and end-to-end security. For example, the gateway deals with conversion between HTTP and CoAP, for example, TLS to DTLS, for example, yeah, because different modes are involved. One is the IoT world, the other is the internet world. So a lot of translations, proxies that take place. So whenever that is happening, you lose the end-to-end security chain. How to deal with that? That is a very important aspect to consider in security of gateways. Secure onboarding of these devices. So the end nodes, how you actually bring them on board to the gateway in a secure way, it's also very important. Yeah, most of us, when we implement gateway to end node connectivity, we hard code a lot of stuff that leads to a lot of vulnerabilities in terms of security. Secure boot, firewalls, all of us know about it. So most of the information listed here looks similar to what we see in a smartphone. For example, if you want to attack a smartphone, you have to consider the threats that are possible on a smartphone, right? So all of our smartphones are acting as gateways. It can be a BLE gateway, for example, right? So most of these information that is applicable to gateways, we can think of it from a smartphone perspective. Of course, intrusion prevention systems, it's absolutely a must for gateways. We have to have really good access control policies. Root of trust and trusted platform module, they're also very important to be considered for gateways. And security updates. So most of the patches, security updates, firmware updates, whatever happens, even for the end devices, it's usually routed through the gateways. So we really have to make sure end-to-end security chain is not missed. So in terms of threat model, it's very similar to what we have for end nodes, but it's not as exhaustive because you remove a lot of stuff because gateway can handle more sophisticated stuff, for example. So we have gateway hardware modification, denial of service, disclosure of devices. So end devices that are connected to this gateway, if you have information disclosing them, that can really lead to lack of sensitive information. For example, in medical field, smart medical devices, where a lot of sensitive information is being transmitted, if you know the device nature and that is disclosed through the gateway, it leads to really huge loss of sensitive information. And you can also create a sinkhole. For example, you can reroute some part of the data to unwanted sources. That also leads to denial of service. Selective forwarding of some information, that can also lead to a lot of disruption of services. And all these happen because of one or the other vulnerability as listed here. So I will ask Devesh to come over and take it forward through application security. Thanks.
Thanks, Vikas. Since Vikas has been explaining all the different areas that are there in IoT, and application is also a biggest component, and since we are using the similar application, be it mobile or web, the attack surface also it's very similar. So as you could see, there are mainly three parts from where a threat can come, be it network, host, or application. So at the network layer, it's again at the spoofing of packets, and at the host layer, there are like buffer overflows, and at the application layer, OWASP still holds very good. So all the attacks like cross-site scripting, SQL injections, and information disclosures, all those attacks are still valid, even if we are considering IoT. And as we'll move further in this session, I'll be able to show you guys some of the examples from the DEF CON presentation that are mainly around the applications. So, so now we are moving to the most interesting part of the session. I could see that most of the guys are already feeling security fatigue. So it's basically a term that is when too many security jargons or too many security responsibilities are thrown at someone, he starts feeling a bit low and like demotivated sort of thing. So I'll promise that next session would be more interesting. So so I got a chance to be at DEF CON and Black Hat this year. There were like many talks around different domains of security. As you could see, on the left-hand side, there are talks from Black Hat, and then on the right-hand side, there are talks from DEF CON. These two conferences are organized by the same set of people, so they happen like almost overlapping manner every year in Vegas. So Black Hat is mainly focused on the attack and defense side of things, while DEF CON is like more of a hacker-driven conference wherein more focus is on the attack side of things. So you'll see all cool sort of demos there. So as you could see, we have summarized the type of talks based on the areas. And Internet of Things are like among the top 5 domains that were presented there. And in DEF CON, it was like having the maximum number of talks. So and that also justifies the fact that DEF CON is more on the attack side of things. So you could see that people are more attacking the Internet of Things devices than actually figuring out the defenses for it. So let me get into more details of the talk. So I hope this is viewable. I know it's not audible as well, now it's not viewable as well. So I have basically categorized it into further details as to which areas the talks were presented in. And as you could see, Internet of Things is again at the highest numbers. So that means lot much research is going on around Internet of Things, devices, hacks, and defenses. So we have summarized some of the key talks that were there in Black Hat and DEF CON this year around IoT devices. So let me just give a brief overview of some of those talks, and then we'll do a deep dive in one of the attack methods. So these are some of the top talks that we saw this year in DEF CON and Black Hat. So BUSA is Black Hat USA. So the first one is building trust and enabling innovation for voice-enabled IoT. So it was very interesting to see. It was a kind of group that they are planning to make. It's an organization, an open source driven organization, which will be working on the privacy of the voice enabled devices, like something like Amazon Alexa or Siri. So as of now, there are very less privacy driven things around the voice enabled devices, and we are not even thinking about the security of those devices. So though if and you can go ahead and basically look at their website. It is known as VPA, Voice Privacy Alliance. So they have started drafting controls around privacy in voice-enabled devices, and it's a very interesting thing. So as of now, it's very again at the starting phase, and you guys can also participate as you guys would have been doing with OWASP and other open source organizations. So the second one was the it was named Let's Get Physical Physical, and it was the attacks against the network security devices like your CCTV cameras or your internet connected doors. The third one was again a very interesting, and I was amazed to see this one. It was a worm that Colin O'Flynn and Eyal, he's from the same research community. So these guys are basically developing a worm which has the capability to spread itself from one light bulb to other light bulb. So they basically demonstrated a demo using Philips Hue light bulb, wherein they mounted this attack device on a quadcopter, a drone, and then they made it fly around buildings which were using Philips Hue light bulb. And basically, they showed in the demo that those bulbs started to fluctuate. And then later they showed that most of the security companies were hosted in that building. So it was very cool to see that demo. So basically what they did is these light bulbs work on ZigBee protocols or ZLL. So they have a central controlling system, and then the actual bulb. So there will be a controller and the bulb. So the controller talks to the bulb in ZLL. So you can basically sniff in between using, there are certain sniffers that comes, and you can basically send unwanted commands to control the bulb. So the detailed video is out there, and it's very interesting to see that. So we'll move on to the next one, which was the autonomous car hacking. So car hacking is always a real cool thing in DEF CON and Black Hat, but this year it was kind of low because the famous car hacking duo, Charlie Miller and Chris Welsack, these guys has shown like multiple car hacks in previous conferences, were not able to demonstrate it due to some political reasons, further car hacking, and I think they are giving up car hacking after this. So this was their last car hacking demo, which they gave on the CAN bus hacking. So these guys basically do CAN bus hacking, and then start from the infotainment system, and then get into the other controls in the car. But that was not very interesting, but because this year it became the connected hacking, because the car manufacturer basically disconnected the remote connectivity of the Tesla car. So the other autonomous car hacking demo which I liked was from some Chinese hackers, and it was named "Can you trust autonomous vehicles?" So autonomous vehicles are so basically when you classify the how should I put it, autonomicity of a vehicle, it's like it is divided from a scale of 1 to 5. So above 3 to 5 are considered automatic. So 3 would be like somewhat automatic, and then 4 would be like even more, and 5th will be like fully automatic, something like Google-driven automatic car. So these guys showed a car which was at level 3, and basically hacked into the parking sensors. There were like couple of millimeter wave radars, ultraviolet sensors, which helps car to do automatic parking, self-parking. So what they basically did is they so let us first understand how does these automatic sensors work, right? So they will basically consider a UV sensor. So they'll basically emit UV radiation, and it will hit the target. It will come back, and then based on that piezoelectric effect, it will calculate the distance. So these guys were able to basically jam these sensors by emitting extra radiations. So sensors has no mechanism to basically check whether the radiations are from the actual object or from a emitter which was hidden by the attacker. So they basically fails and could not identify the objects. So similarly, they hacked into millimeter wave radars and couple of other sensors of the Tesla car. So that was also very interesting talk. The last one, which is around the BLE devices, is the one which I think was one of the most interesting talk, and it was named picking BLE locks from quarter a mile. So it was by Anthony Rose. This guy demonstrated hack on the Bluetooth locks. So as you would have seen, there are many Bluetooth devices that are coming up every year, and since BLE gives you immense capability because of its low power consumption nature and its outreach, it has become immensely easy to create new devices. But then no one is caring about the security of these devices. So let us first see how a Bluetooth or a typically Bluetooth device works, right? So Bluetooth has multiple layers. So the top one has, if I have to break it into 3 parts, the first one would be the profiles. Second one will be the GAT layer in particular, and then third will be SCI. So depending on what device you are developing, you can select multiple profiles, and then what these guys did, these guys basically gathered all the Bluetooth locks which are there and started their research on breaking these locks. So when I say Bluetooth locks, it's everywhere. So even Airbnb uses those for their rental networks, right? So they'll put Bluetooth locks, and if you have to go and rent a house from Airbnb, you'll basically receive the lock codes in your phone, and then owner will send you that, and you can basically go and rent that house. So that is how things are working. It is there in your car locks. It is there in your bike locks. So in Western countries, it's like everywhere. So it becomes very critical to secure these devices. So basically, what these guys did, they got a device called Ubertooth 1. So how many of you know Ubertooth? What is Ubertooth? Okay, so Ubertooth is nothing but it's a small hardware device. It was developed by Michael Osman, and basically what it does is it allows you to sniff Bluetooth traffic, right? So it becomes much easier after that. So once you are able to sniff something, you can analyze what sort of data it is carrying, and then you can play around with the data and see what can be done. The other one was the Bluetooth dongle, and then they basically had a high beam antenna so that they can capture a long range sort of Bluetooth emission. And then Raspberry Pi. Raspberry Pi is optional because if you don't want to use your computer, you can basically host everything in Raspberry Pi. It's very handy to carry wherever you want. Plus, even if it is lost, you'll not lose too much. And if you are caught in legal actions, even then it's not a big loss. There were multiple locks that were, there were multiple attacks that were shown against Bluetooth locks, BLE. So whenever I say Bluetooth, it's like BLE. So please don't get confused. So the first one was the normal sniffing that these guys showed. So they basically built a device uh, with a high beam antenna and mounted Ubertooth on it, traveled across the neighborhood and started sniffing. Right? So what they saw was not surprising. There were many Bluetooth logs that they could see, and then most of them were having a clear text password. So the other thing was to basically capture those passwords and then send it to the device so that it gets unlocked. So it's very easy. And when I'm saying that clear text password, it's very common. Encryption is still not there in most of these devices. So the second one is for the devices which are kind of thinking that they are secure because they have AES 256. So they demonstrated one of the device, and I've named a couple of devices here, which were claiming that they were having 256 AES encryption. So what he did basically captured the packet as it is with AES encryption, and then replayed the same encrypted packet to the device, and it got opened. So so that these are known as replay attacks. There was another interesting attack that they showed that was for a particular BLE lock manufacturer that is known Okie Dokie. So what he claimed that after he disclosed this vulnerability to them, they actually shut down their website and they are not responding. So so he did basically responsible disclosure. So you cannot disclose vulnerabilities like this until unless you disclose it to the vendors. So so these guys were having a good security with AES, as they claim. Plus, they were having a custom developed encryption key, which they were doing a XOR with their AES 256 encryption key. So he captured the packet. What he realized that there is an opcode and there is a message part to it. So when you do fuzzing, you basically play around with any sort of data and you don't have any clue what to do, right? So he basically flipped the third bit of the opcode and sent it to the device. The device did not understand what it is, and because there was no fail-safe defined for the device, it basically unlocks itself and then fails. So so that is what fuzzing can do. So I assume that most of the BLE developers here are taking care of that. The fourth one is with the application side of BLE. So, and it is common for all the mobile applications. So I'm considering, say, for example, an Android application, right? Those are APK packets. So and if any Android developer here or any Android tester here, he would be understanding that you have to basically do in order to analyze those packets, you have to do dex to jar and then take out the class files, and then basically rest of the things are analyzing the source code. So same goes for all these Bluetooth applications, because in the end those are mobile applications. And then what they have demonstrated in this analysis was that most of them were having hard-coded passwords. So when I say hard-coded passwords, there are three types. So you should not get confused with default passwords. And then there are hard-coded passwords. And then there are hard-coded encryption keys. So default password is nothing but that is default for the device, and it is given to you in some form. Maybe is there in a user manual, or they'll email you. The second one is the hard-coded password, which you cannot do anything about. It's there in the firmware. So it's hard-coded by the developer to make the shipment process easy, or for any other reason, because it becomes so much easier. So for example, if you are developing 20,000 devices, it's better to hard-code it, right? So why would you even take chance to, or take trouble to email or use some other means to tell the password? So most of these were having hard-coded passwords in the application, and it's very risky. As I was talking about the Mirai botnet, so those were also the default password devices, mainly DVRs, which is considered to be made from a Chinese manufacturer called Xiaomi. So they are recalling those devices, but I don't see that at this point in time a solution because the damage has already been done. And if I have that since like few years, I might not even consider returning it to them now, right? So I don't understand the process. So so that is very important to have uh, care in not having default passwords or hard-coded passwords within your applications. The fifth one was kind of tricky, and it is known as device spoofing. It basically works for the device or the locks in this case, which has the a third component to it, which is known as web server for authentication, right? So let me explain, and it was very interesting. So what these guys did is basically they did it for a lock, which is a padlock, and it is known bit lock, right? So as you could see on top, that is the actual lock. And then what attacker does, attacker basically sends a packet to the lock, try and connect to it. Lock sends a nonce value, which is like any random number, which is not known to attacker. Attacker obviously don't have the username and password for the lock. So what he does is he basically sends any random username or password or key, for example, which is wrong, obviously. What device does after receiving that, it sends that the password is wrong and then notifies the attacker with another nonce, which is n+1. So now what attacker understands is that with every ping, what it is doing is basically incrementing the nonce and sending it to the user. So that is what he needed from this point. So he understands how the device is working. The nonce which has to be random is not actually random. So just by providing some random password, he is able to figure out the predictions, the next nonce value. So what he does after this, so there are if people here are working on Bluetooth, they'll understand there are things like Bluesy and Blueno. Have you guys worked on it? So you can basically profile a complete Bluetooth device using Blueno and basically make it look like your device. So that is what he did. So it is known as man-in-the-middle attack in terms of Bluetooth locks. So the attacker hosted a fake device, and you could see on the center there. And he waits for the victim to come. And he has created the similar copy of the actual device. And then when victim is the user here. So as soon as he comes, he thinks that his actual lock is the attacker, right? So he'll send a connect request, okay? And then user will send the next value of the nonce because he already know what nonce the device is expected to send after the next value because he has already captured the previous one. So user will receive the n+2th nonce, which is correct. User will send it to the web server for encryption. Encrypted value will be sent to the user back. User will send it to the attacker again, and attacker has everything. So that is what is required in order to unlock the Bluetooth device. So basically, this is known as man-in-the-middle attack of Bluetooth devices, and I like this attack very much because it's like it's there in the wild, and there will be still many locks which are relying on not so random nonce values. So in this case, it was n+1. It can be some other random number which is easy to predict. So please don't code in such a way that you are giving hints to the attacker that your random token can be predicted. So in the end, we are, as Vishwas mentioned, we are trying to define controls for IoT security. So these are very generic, and I have catered it to the Bluetooth specific thing. And this is particularly around Bluetooth devices, which I feel should be there in order to have a secure connection and secure Bluetooth application. So encryption is obvious, okay? And then we have seen what can be done if the nonce value is predictable. So it has to be a random nonce. Strong passwords. uh, we still don't believe that we need a strong password, and that is how people are actually attacking the applications or any other servers because of weak password, because you can brute force it basically. Multi-factor is always a plus, and please don't use hard-coded passwords. So I'll